His hand.
All right, we're doing a little bit. What was that? Kind of phantom hand?
Yeah.
Okay, so we're doing this problem right here in which a dangling mass and a table-bound mass are attached by a rope, right? And they have the same mass. There's no MA and MB. I mean, you could talk about mass A and you could talk about mass B, but they have the same mass, so we're calling them each mass M.
Right.
And the problem begins where everything's at rest and we are a distance h above the flow. What is the total length of rope?
4H.
The rope is 4h long, so we've got 3h for block A to travel before it reaches the edge of the table, and we've got 1h for block B to travel before it hits the flow. And they're gonna ask us some questions about what the heck's going on, right? First question, determine the acceleration of block B as it descends. This is a classic physics question. This is called a Half-Atwood's machine. An Atwood's machine would be a pulley with a mass on one side, mass dangling on the other side. We're looking to figure out what if there's a mass dangling and another mass that just is there. The only effect that this mass is gonna have is that it has inertia. Okay, so how do we find the acceleration of block B?
Free body diagram.
Free body diagram of what?
Block B.
Free body diagram of block B. Okay, so a free body diagram of block B says there are two things on block B. What are they, Sophie?
Tension and MG.
Which way is tension?
Up.
Okay, tension is up and mg is down. Question, are they the same length?
No.
What? What? Less? Which one's less?
The tension's less.
Oh, tension's less. I'm gonna draw it like that then, because the block is falling, not because the block is falling, but because the block is accelerating downward. So it has a net force on it downward. I know those can't be equal. So you wanna tell me what the acceleration of that block is? What we're gonna do, some Newton's second law? Let's define this direction to be positive because that's the expected acceleration of the system. Okay, mg minus t is the net force, which is mass times acceleration, and the mass is just m, so we can write that statement right there and we can put it in a box. Yay. Great, so the acceleration then is that stuff divided by m. We finished?
Why is that wrong?
Oh. So actually, what's funny is Kurt says, hey, I wrote exactly what you just said. A equals mg minus t divided by m, and I didn't get full credit for it. Isn't that what Kurt just said?
Yeah.
Did you guys hear Kurt say that?
Yeah.
Kurt actually said that. Here's the thing. They say express all algebraic answers in terms of these guys right here.
Oh.
Which means you can't have any other letters.
Tension.
Tension offends our sensibilities.
Gosh darn it, tension.
It is an unknown, and it is unacceptable, Kurt. You're out of here. What do we do? How are we gonna get tension? We gotta try to get tension.
Solve for tension.
Pay attention. How are we gonna solve for tension? You wanna solve this equation for tension? Ha! You don't know acceleration. So we're at a standstill.
So let's do some kinematics. No.
Can't do kinematics now. We don't know enough. We don't know enough. We don't know tension, we don't know acceleration. It feels like we got two unknowns. When I have two unknowns, I feel happy when I have what?
Gravity.
Two unknowns and two equations. This sounds like we're in an equation. Draw another free body diagram, but what else could there be in the problem?
But there's the other mass.
Oh, the other mass. You want a free body diagram for the other mass?
Yeah.
Okay, I will do that. We'll do that in green. The other mass has forces acting on it. Sophie, what are they? This mass right here. Tension, which way?
To the right.
Okay, I'm gonna call to the right the x direction. Is that okay with you?
Mm-hmm.
I'm shifting the x direction because of that pulley. I mean, the pulley that you can't see right there. That pulley. The one that ought to be there because there's a lot of friction if a rope rubs against the edge of the table. Okay, so tension is to the right. What else, Sophie?
MG is
I'm
down.
yeah, MG is totally down. I'm gonna put an arrowhead on that. And then MG is down. What?
There's
Yeah, sure. I can do that. Oh, let's go crazy.
Yeah,
Arrowheads
do it on
yeah,
there.
I'm gonna do it. Yep, there we go. Okay, what else? Sophie, come on. What else?
Friction.
Ooh. Now,
No.
that's an interesting point. I'm reading this. Maybe you guys on the internet didn't read this yet, but it says block A is placed on a smooth tabletop. Yeah.
Just kidding.
Tabletop says, hey, ladies, it's smooth. It's got the moves. It's got no friction.
Does it have like lard on
Okay,
it? or
normal force?
something?
Yeah, it's got lard on it. That's why it says, hey, ladies. Okay, Fn equals, all right, then we're, it's not very inviting. What's wrong with you? That was Kurt, internet. Just so you know.
Gosh,
I'm gonna do the free body diagram. What do I do? That's Newton's second law, right?
Yeah.
Aren't we supposed to do Newton's second law now?
Let's do it.
Okay, let's do it. Newton's second law says...
Wait, extra.
In the x direction, let's just talk about the x direction. Net force in the x direction, mass times acceleration in the x direction. The acceleration is just going to be a. Don't you think they're going to have the same acceleration?
Yeah.
I think they will.
I could agree with you.
That
there.
takes care of it.
So what is the net force in the x direction?
Tension.
It's just, there's only one?
Yeah, it's just tension.
Okay, tension.
And now we
I'll
can
put a box around this.
do like some substituting.
You got 2 equations and 2 unknowns. You like to substitute at that point?
I do like to substitute.
Me too.
Question.
I only
Quick question.
When?
You have only a moment.
When does something deserve a flower pot?
When it's awesome.
Okay. That's good enough.
Okay. Now, I'm gonna plug this into here.
It's a pretty long arrow.
Yeah.
You could have just, like, gone across.
No, it would be crowding the system. You have no sense of aesthetics.
But you have to be able to follow it. That's a long way to follow that arrow.
I know, but I assume that my viewers have a lot of patience. They're like, oh yeah, he's drawing an arrow. Oh, well, I guess I'll keep watching.
But what if there wasn't enough friction and you were like going too fast and you were like,
Yeah, what if you just? What if there was no force that like acted in the other direction?
What if me drawing on this paper was actually a physics problem?
You could totally do it.
What if your Parkinson's made it off?
Oh, that's really funny. Bring that up again. That's great. Good work. Listen, listen. What are we doing here? Can we improve Kurt's answer so that he can get some credit and we can move on?
Yeah, we can
Yeah.
do MG
Kurt,
minus
what are we doing? MG minus what?
MA.
MG minus MA. Whoa, where'd you get that? That was fancy. Equals MA? That's what the substitution gives us, right?
Yeah.
Okay, all I want is A.
Okay.
do we need to? Oh wait, never mind.
But now there is everywhere. It's like when there's that what's that broom, and
can-
then
you
you
can
go
hear
at it
the
with a
M's.
hatchet,
Yes.
and then there are more magical brooms everywhere.
Can't you cross out the M's here?
Can I cross out the M's here?
Yeah.
There are M's everywhere also.
No,
Let's
you
kill
have
them.
to-
Get them.
Kill them. No, we're gonna kill them all. Watch this.
Fire.
Fire, red,
Yes.
kill, dead. Now what?
Well, now
G
you got-
minus A equals A.
Well, just like add A.
You want me to add A to both sides or just to one side?
To both. Why would
G
you add A to one
equals A plus
For
A.
kicks.
Well, that's nice. I'm going to factor out an A. That's A times 1 plus 1.
I don't know why you would do that.
Because I'm formal.
Okay, just divide by 2.
I'm wearing a tie.
You should have said 2A.
You're not wearing a tie.
I'm not, so I'm gonna be informal.
Okay, so A equals G over 2. Look at this problem again. Look at that. When I see these 2 blocks, I think, dang, you got 2 blocks and only one of them's feeling baby G. See?
So then,
So you're gonna get half baby G.
yeah, because it's like baby G spread out between 2 things.
Sure. It's like only one force of mg, but twice the mass. So half baby G.
That's
So-
quite interesting.
Seems fair, doesn't it? Now, they want to determine the time at which block B hits the flow. Now, obviously, it's important to know the acceleration in order to do that, right? So we're gonna keep that as we go on to the next page. The next page is where we do part B. Block B strikes the floor. The acceleration of block B and the acceleration of block A are equal at G over 2. How long does it take something to fall a distance h if its acceleration is G over 2? Go.
We know the height or the distance it falls.
Okay,
is h.
you thinking of an equation? Or should I write delta y? Should I write delta y equals?
Negative h.
Negative h. Listen to that. Awesome. Awesome. Now what?
And then acceleration. Oh, we know that.
I already wrote it down. Should it be a negative? If we're gonna say delta y is negative h.
Yeah.
So now
sorry.
I'm doing this problem where this direction is the y direction.
Why
So
did we change that up?
I don't know, it just feels more natural. Just whatever. Yeah, okay, so that's gonna be a negative acceleration. Okay, then what?
These are released, right?
For reals. Yeah.
So the initial velocity is 0.
Initial velocity is 0. What else?
In which direction, though, Kurt?
All directions. Now, we're trying to find time.
Classic.
The classic will do it for us, you think?
Yeah.
Let's try it out. The classic, as I recall, says something like, what is this? Teal. The classic says delta y equals the initial velocity in the y direction times time plus 1/2 the acceleration in the y direction times square. Okay, so what are we supposed to do? We're supposed to
Kill
circle some part and say that it's 0.
velocity
Kill
initial.
velocity initial. You know what, Kurt? It's already dead. I found it that way.
That's kind of sad.
Yeah. I mean, but it wasn't my fault, at least.
True.
Trying to solve for t. And you get a 2 delta y divided by ay and screwed it.
Yeah.
Okay, time to plug in some of the business.
So just plug in delta y.
You want to tell me what it is?
2 times
negative
negative h.
2 times negative h.
Or
Divided by negative g over t.
Ew.
So. Just,
I have some reticence at doing this,
I mean,
but I
we
will
can,
do it.
We can work it out later.
Why
See,
is
we
it
can just,
Alright, let's work it out.
Just multiply by.
Yeah.
Is it over 2?
What? We already worked through that. Watch the video.
2 over negative.
You can just multiply by.
Latecomers will not be tolerated. Prem, what are we doing here?
You should totally multiply by 1.
What? How the heck are you writing 1? Are you gonna write 1 like inside this scroot as 2 over 2?
I am.
Wow, fancy.
I know.
So then I would get, I'm gonna multiply by negative 2 over negative 2.
Oh, wow.
I'm gonna get 4h. Isn't that a program for youth in the country?
What?
4h?
I don't know.
These youths.
What did you just say? Okay, great.
I don't know
So
what.
there's a g right here. Look at this. Look how fancy we could be. We could even take out the 2. There I am.
wow.
There I am. Look at that. All right, so that's how long it takes. You guys okay with that? Check it. Would it make points for Kurt? Does it obey the rules? Does it play by you have to only have H, M, and baby G
But there's
in it?
t.
But that's when we were solving.
Dang it, man! No, listen, this answer doesn't have M in it, and the other answer doesn't have M in it. So I suppose we're getting some cool symmetries by the fact that they're the same mass. That's cool. Regardless of how much mass it is, they would always take this long to hit, and they would always have that acceleration of half baby G. Where are we going now? Wanna do the next part?
Yeah.
Okay, it's asking for words. Oh, how I hate words. Describe the motion of block A from time t equals 0 until when B hits the flow.
It's
What does A do?
accelerating.
Be accelerating because of a net force, constant net force.
That is very fancy. It is a fine and eloquent answer.
You should
One
draw
thing that I heard wrong was that A goes to the right. Now, there's nothing actually wrong with the statement, but it doesn't fully address the motion of block A. Fair enough? So if you can tell me whether it has acceleration or not, that would be very important. So we say A accelerates to the right.
Or in the.
With an acceleration of g over 2, right?
Yeah.
Yeah, we even know it's acceleration. And, oh heck, we know how long it's been accelerating also.
For that number.
That time right there. Yeah, so we actually know a lot about block A, which is gonna come in handy when we get to the later parts. But let's read problem D. It says, describe the motion of block A from the time B hits the flow and the time A leaves the table. Now you understand, B hits the floor, boom, what happens to the tension?
It'll stop, or the tension will hit 0.
Tension immediately goes slack. There is no rope pulling it anymore.
And it'll just go to the right without accelerating.
You're saying like there's no friction?
Yeah.
Because of the lard, right?
Yeah.
Right, because we grease the
Hey,
table
ladies.
so that, you know, it's just like,
That's right. That's right. So, meanwhile, we're ready to go on to part E.
Yeah.
Do you have any questions on D?
So if I want the ladies, I should rub myself in lard?
I think that's the lesson
That
of
is
the
the moral
video.
of the story.
Yeah, that's for if you want to be fast at swimming.
That's right. That's right.
Oh, yeah.
If you want to be smooth.
No,
like-
if you want to be fast at swimming, you rub yourself in Vaseline because it's waterproof.
That's illegal though.
Yeah.
Is this seriously illegal?
Yeah.
Like against the law?
Do
Yeah,
they check
the
you for
sport.
Vaseline and how?
you'll get kicked out.
Against the
And
law
there's
of the
some
sport.
there's some rule about shaving your legs.
Yeah,
like-
don't they not let you shave your legs?
Well, it's like within a certain amount of time.
It's really because people would like.
I mean,
shave their
I don't
legs
care
before,
about
so
those
they could, you know,
rules.
go
Wait,
fast.
is that a
thing? Like you can't rub Vaseline on yourself?
Yeah,
Does that actually
they're like
help that
waterproof.
much?
They're like waterproof.
I just want to be clear
It's not
for the
actually-
internet people, this is not during class time. And that's why I've allowed this to get so off topic. I think it's time to get back to work. Can we do part E now?
Yeah.
Okay. Determine the distance between the landing points of the two blocks. Would you believe that I can tell you right away where block B is going to land? Here, I'll let you look at that picture. Can you tell me?
Yeah,
Where does block B land?
directly below where it is. Right
It just hits the floor and then sits there. Okay, what about block A?
it goes past block B.
Why?
Because it's moving. It has an initial
Higher
velocity.
initial velocity.
In the
Extra.
Okay, so now we're defining x and y. Now we've got ourselves a kinematics problem, right? We're going back. We're going back to kinematics. Don't you think it will be making some kind of parabolic path? It'll be going like whoopsie doozy right over here.
Yeah.
And then the rope will be, but B will be here and A will be here, and we're trying to find that distance right there, which we could call
Delta
D.
X.
You want to call it delta X?
I like
you
delta
feel
X.
informal. You might be able to wear a tie next week.
Oh, okay.
Listen, I will approve you wearing a tie. We have to find out how far it goes. How do we do it?
Well, what equation to
Delta X
in?
equals VOX delta T.
You doing some classic?
Mm-hmm.
In the x direction, the classic's very simple. How far it goes is the initial velocity in the x direction times the time it spends in the air.
Yeah.
Okie dokie. So we turn that in and we're finished with the test?
No.
Ha! It has none of those and two things that aren't allowed.
Well, then we have to find V naught X, and we can just substitute for
We
time.
know the time. Are you suggesting that we know how long it takes block A to hit the floor after block A leaves the table?
That's exactly what you said.
Because I believe we found the time it takes block B to hit the floor.
We did.
But block A is very simple. It's just free fall.
Are you suggesting that it's not the same time necessarily, but it is?
Definitely not the same time.
It is not necessarily the same time. You don't. What I'm saying is you don't know it to be the same time, and you can get it in a different way, but you don't a priori know that it is not the same time. That it is explicitly a different time.
Yes.
Okay, all right, let's do it then. Donovan thinks he knows how to find the time of a projectile falling.
Classic in the y direction.
Classic in the y direction. Classic in the y direction with no initial velocity in the y direction, right? Super easy. We're talking about delta y equals 1/2 acceleration in the y direction times time squared. We're going to solve this for t. We're going to say that it's equal to the square root of 2 delta y divided by ay.
AY is G.
Ay is g now. We want to be careful because we have a different
exactly
problem.
why
It's
I
totally
said
baby g.
That it's definitely not the same.
Assuming it's not like a...
Okay, so ay is g, so I got 2 times, and what's delta y?
Negative 2h.
Is it negative
No, it's just negative
h?
Oh no, it's
What we're asking is
Oh, wait, no,
how
you're right.
far the block A falls.
It's
It's
fallen
4.
2H.
no, but it goes once B. Oh wait, never mind.
No, yeah, because the height of the table is 2H,
Yeah,
and
it's
it goes
2H.
from there down.
This right here, this time is time that A falls.
The other time
So
is-
I'm not including the time that it's traveling across the table. Nobody cares about that. I want to know how far it goes from the time that it hits the edge of the table to over to here. So what is delta y for block A? It's 2h, but it's negative 2h actually, right? And what is A sub y for the block A?
Negative 9.
Negative baby g. Take a screw right here.
And just take out the negatives.
Take out the negatives. I'm gonna factor out a 2 if that's okay with you. And I'm gonna get, watch this.
I'm ready.
Watch this, Donovan's gonna like this in particular. 2 times the square root of h over g.
I don't know.
Why am I in particular gonna like it?
It's the same time! It's the same time exactly. Which is wonderful coincidence. And I just don't want you walking into a problem and saying, I know that that's not the same, because you don't even know, you just met it. So you gotta work through it. There was this 2 here that surprised you, wasn't it?
Donovan, I
Was it
think
the
we
2?
should see the shame on your face in the YouTube video.
Would you mind putting your face in there?
Shame.
Put your face in there, actually.
All right. Let's go on, because I found t, and I found t in such a way that we have only permitted variables there. But I'm trying to find v sub naught x.
Are we finding it?
Then find
Well, we know
the
that
initial.
V naught.
We know
Y.
V final is 0.
V final is 0 in the x direction. Shoot, v in the x direction is constant.
In the
Well,
Y
it's a
direction, it's
projectile.
0. Oh wait.
We've already finished the y direction. We looked at the y direction to find time.
Yeah, but-
There's nothing else we can get from it.
Don't we find V in? Well, we use a different equation in the y direction.
You want a different equation
Yeah.
in the x direction? Oh, a different equation in the y direction. Oh, no, I don't think so. I think what I'm trying to find is how fast block A was going when it reached the edge of the table. That has nothing to do with projectile block A. This is pre-projectile.
In the X direction, V naught X equals V naught final.
In the x direction, v naught x equals what?
V naught final. Or V final.
Yeah,
X.
totally. But nobody's giving me any handle on how the heck fast the block is going.
Why don't you just do 3h over t?
3h over t doesn't have the right units of acceleration. We're gonna need to get an equation to find. Oh no, I'm sorry. We were looking for velocity. 3h over t. How would you get 3h over t? And what time would you use for t?
I don't know.
Okay, that's not gonna work for us. What should we do? I'm gonna get some pink ready, so as soon as you guys have something to say, hot pink. The hot pink is ready.
Can we use magic?
Stay focused.
Wait, which one are we trying to solve?
I want you to tell me how fast block A is going when it reaches the edge of the table. Now, the question is,
Wait, we know it's acceleration in that direction. Time. So can't we? And we know the time it.
we know how long it accelerated, and we know what the acceleration was, don't we? Okay, so I'm gonna write a little BT dub over here. Isn't that hot pink great?
So smart.
We know that the time accelerating is, what was that time accelerating?
2 roots of h over g.
Nice. Well stated. This time accelerating is this time right here. That was the time that block B was in the air. So it's the time that A spends accelerating, right? Because that's the time during which there is a tension, right? And so this is 2 root h over g. And what else are we gonna do? Oh, we're gonna multiply by the acceleration?
Yeah.
Acceleration during that time was what?
G over 2.
G over 2. So what could we do if we were trying to find the velocity?
Just stick them together and divide.
Was that some kind of equation? Stick them together and divide? What are you talking about?
To the power of blue.
Divide to the power of what?
Blue.
Divide to the power of my fist in your face.
Wait, no, don't divide his face with your fist.
That's a good point. What are we doing here? Come on, guys. You know physics equations. I can't put this on YouTube. They'll laugh us off YouTube. What?
Velocity equals initial velocity plus acceleration.
I call that velocity equals velocity plus. I call that the definition of acceleration.
Yeah.
So you want to solve that for what it's already solved for, and you want to plug in initial velocity equals
0.
Okay, so I'm just supposed to multiply these two things together. Literally, I'm multiplying these two numbers together.
Yeah.
All right, what do you get? It's kind of weird looking, right? Because it looks like it's g over 2 times the square root of h over g.
When those two.
There it is.
Yeah.
G
Kill, yeah.
Fantastic.
And what else? Now I've got g times h.
Over g.
Yeah, but that stuff's rooted.
Yeah.
So what does that do? Do you know your way around a square root?
Maybe.
Square? Right? Is that it?
No, then we have to square the whole.
The square root of h over g to the third.
No, this is in the numerator. You want to put it into the square root?
hg.
It is the square root of hg. Having redeemed himself, Donovan goes home happy.
No,
Not yet.
leave now.
No, he's cool. We're supposed to take this, which is the velocity, and multiply it by the time, which is over here. Let's do that. So we say, finally, we're answering the question, delta x equals the square root of gh. I prefer to see them like that because it's alphabetical. And then I'm going to multiply it by 2, and I'm going to multiply it by the square root of h over g. Oh, gosh. Oh, that looks really cool. Doesn't that look cool? Like something should happen?
Yes.
Like there's magic in the air?
Yeah, I mean, I told you to use magic.
Here we are. It's Christmas. It's a Christmas
No, it's
miracle.
Hanukkah.
What are we doing?
Multiplying.
Do it!
The square root of h squared.
Post-Thanksgiving.
This 2. Did you just tell me that it's 2 times the square root of h squared?
Yes, I did.
Okay, that'll be really fun. I'll write that and see how people feel about that. H squared screwed. Is that what you just said?
Yes, sir.
Okay, I heard it too. Joey, did you hear that?
Can I go?
Yeah.
We're not quite finished. Isn't that cool? Look at this problem right here. It's 2h.
Oh my god.
Isn't that cool?
Oh my god.
Yeah.
I'm so freaked out right now.
Huh?
This is scary.
It's spooky.
Spook Tour 2015.
Cool.
Yeah.
See ya.
Okay, bye.
All right.